All right, let's jump right into a really fascinating puzzle that sits at the very heart of logic. It's a problem that seems pretty simple on the surface, but solving it actually required a complete revolution in how we think about truth, reality, and, well, unicorns. So, I want to start with a quick question for you. Just a gut check. Don't think too hard about this next statement. Just decide for yourself. Is it true or is it false? All unicorns have horns. Now, I bet most of us would say, yeah, of course that's true. That's what a unicorn is. And you know what? You wouldn't be wrong. Exactly. But here's the thing. In the world of formal logic, that simple, totally obvious answer creates a massive system-breaking paradox. And that brings us to our first big idea, this unicorn-sized paradox. Let's really get into why this one little sentence can basically break a system of logic that we've been using for more than 2,000 years. The whole problem really comes down to this one key concept, and it's called existential import. Now, that sounds a little technical, but it's actually a pretty simple idea. It just asks, when we say something, are we automatically assuming that the thing we're talking about actually exists? And for most of human history, the answer was, well, yeah. Okay, so this is where it gets kind of wild. Under the old rules of logic, if you say that all unicorns have horns is true, then you are forced to accept that some unicorns have horns is also true. And see, that's the trap. That second statement is basically saying, hey, unicorns exist, which they don't. And you just can't have a true statement logically lead to a completely false one. The whole system just, well, it breaks. So to really understand how we got into this mess in the first place, we gotta go way back. We're talking about the original rules, the ones laid down by Aristotle himself. And you can see the old way of thinking was pretty straightforward. I mean, Aristotle's logic was built for the real world, right? It just kind of took it for granted that if you were talking about something, whether it's people or swans or even triangles, you were talking about things that actually exist. It didn't really have a folder for things that don't exist. And this right here, this is the specific rule that springs the trap. It's called subalternation. You can think of it like a gear in the machine of logic that connects the big picture, the universal, to the smaller picture, the particular. It just says that if a rule applies to all members of a group, then it has to apply to some of them too. And that sounds totally reasonable, right? I mean, it makes perfect sense unless there are no members in the group to begin with. Okay, so this is where things get really, really clever. Fast forward to the 19th and 20th centuries. You've got these brilliant minds, logicians like George Boole and Bertrand Russell, and they basically decide it's time to rewrite the rules. They came up with a whole new kind of logic, a sort of what-if logic. And the absolute core of this revolution was this idea right here. They said, look, a statement like all X are Y isn't actually a claim about what exists in the real world. Instead, it's a conditional. It's a hypothetical. It's not saying, hey, X's exist, and by the way, they're all Y. What it's really saying is, if something were an X, then it would have to be a Y. See that subtle shift? It's huge. So let's apply this to our unicorn sentence. All unicorns have horns gets a new translation. Now it means there is nothing in the universe that is a unicorn and does not have a horn. Do you see that change? It's a game changer. We're not talking about what is anymore. We're talking about what isn't. And you know what? That statement is absolutely 100% true. So that's the foundation of the new system. When you put them side by side, the difference is just crystal clear. Aristotle's view, it assumed everything you talked about existed. The modern view is way more careful. Universal statements, the all or no statements, they're just hypotheticals. It's only the particular ones, the ones that say some, that are actually sticking their neck out and claiming something exists. All right, so we've got our new toolkit. Let's head back to our unicorn problem and see how this modern logic finally fixes everything, once and for all. Okay, let's walk through this, but let's use dragons this time just for fun. So, step 1. All dragons are green. Remember, in modern logic, we translate that. It means there are no dragons that aren't green. And since there are no dragons at all, that statement is true. It's what logicians call vacuously true. But now contrast that with some dragons are green. This statement claims that at least one green dragon exists, which is false. And just like that, poof, the contradiction is gone. The two statements can coexist. This system works. So what's the big takeaway from all this? Well, that old rule, subalternation, the one that lets you go from all to some, It's not a universal rule anymore. You just can't make that jump from an all statement to a some statement unless you already know for a fact that the thing you're talking about is real. The unicorn loophole is officially closed. Now, I know what you might be thinking. This all sounds like a pretty abstract philosophical game about make-believe creatures. But trust me, this shift from ancient to modern logic, it has absolutely huge implications. See, this really isn't just about unicorns. This change forced us to be super precise about what we mean. Are we talking about ideas, or are we talking about actual things in the world? By creating rules that could handle these empty categories, like the set of all unicorns, modern logic actually became the foundation for so much of our world, like abstract math and even computer science. I mean, think about it. Computer programming is all about handling variables that might be empty, that might contain nothing at all. And I think the real lesson here is just fascinating. For 2,000 years, an assumption was hiding in plain sight, so obvious that nobody even realized it was an assumption. It really makes you wonder, doesn't it? What kind of hidden assumptions are shaping the way we think right now? What seems perfectly obvious to us today that maybe 100 years from now, a future generation will look back and see as a giant logical loophole that needs a whole new way of thinking to solve?